In this chapter, we'll talk about variables and data types. Take a look at these equations in math. Now, a question for you. What can I do to these equations so that I can improve the readability and decrease the amount of physical effort required? It's simple. I would just represent these numericals with letters. So maybe I would just call this numerical as A, and I would call this numerical as B, and this as C. Now let's see how the equations look after replacing numericals with letters. So this is how they look. Now the equations look a lot cleaner, more readable. Also down the line, if you want to write hundreds of other equations, you don't have to remember the numericals. You can just use the letters instead. So that will save a lot of physical effort as well. So what's a variable here? A is a variable here, B is a variable here, C is a variable here. So from this, let's try to form a definition of a variable. A variable is something that holds a certain data. In this case, the variable A and B are holding numericals, the decimal numbers. Now let's understand variables in Java. We have our first app program. Let's use the same program and make some amendments to it. So now what I'm going to do here is I'm going to find the sum of two numericals. So let's say we have A equals 10 and B equals 4.3. To do the sum of these two numericals, instead of displaying this message, we would just say A plus B. Now if I try to compile this program, the compiler will throw some errors. Let's see what those are. Let's open the command processor and go to the directory where your program is residing. It's in desktop. Let's do CLS to clear the screen. Now let's try to compile the program. Javac, which is a Java compiler. Firstapp.java. So the compiler has thrown some errors, which says it cannot find symbol and it is pointing to letter A. Same is the case with letter B. Alright, what's going on? Java is not a human being. It's a computer. It's artificial intelligence. And we humans, we programmers need to be more specific about the information that we're providing to a machine. By that I mean, it's just not enough if you say A equals 10 or B equals 4.3. We also need to tell Java what type of data this A is holding. In this case, it's integer in case of A. In case of B, it's a decimal point numerical. So the keyword that we need to use for integer in Java is int. This tells Java that the variable A is holding a data of type integer. Now for decimal point number, the keyword that we need to use is double. One thing to note is like I've already mentioned, Java is a case sensitive language. So instead of double, if you say capital D double, then this would yield a different result. Or if you say DO, if you make O as capital, then this would yield compilation errors. So let's not do that. Let's keep it as double. And let's save the file. I just hit Ctrl S. Let's go to command processor again and try to compile the program. The program got compiled successfully. Now we also have a class file here to run the program. Let's do CLS to clear the screen and then now let's just try to run the program. So Java space firstapp. Let's hit enter. Great. It has shown the output 14.3, which is expected. Now to make this output look a little bit more meaningful, let's try to prepend a string before the result. So instead of just saying A plus B, what we do is we'll write a string which says the sum of A and B is the result. Now there is one more thing to note here. The character plus, in case of a plus b, it is used to find the sum of these two numericals. But the plus in here is acting as a concatenation operator, which means it is concatenating what's there in the left and what that comes in the right. Now if you try to run this program, you'll see a strange output. Let's see what it is. Let's compile the program and run it. The sum of a and b is 104.3. What has happened? It's supposed to be 14.3. As I said, the plus character serves two purposes. One, it acts as a concatenation operator. Also, it can be used to find the sum of two numericals. In this case, Java got confused to determine whether this is a concatenating operator or to find the sum of two numericals. So what we want is, we want this plus operator to be a concatenating operator and this plus as a plus operator in math. So we need to put them in parentheses. Now let's just try to run the program. Compile the program and then run it. Cool, now it's displaying the correct result. The sum of a and b is 14.3, which makes sense. So a variable has the following syntax. The data type, which defines the type of data, like integer, and the name that you want to give to the variable, something like this, and the value, actual value that this variable holds. Now let's try to understand what happens behind the scenes when we say int a equals 10. So when we run the program and when the interpreter comes across with this instruction, it will create a memory location to store the value 10. And how would this memory location be identified? With an identifier, which is a in this case. So variable in essence is nothing but this memory location. So down the line, if you do a plus b, the interpreter tries to look at the memory location with an identifier a and get the value inside it and replace this letter a with 10. So behind the scenes it does 10 plus, let's say, 20. Now we have different types of variables in Java, but at this point of time it is way too advanced. After we cover the concepts of classes and methods and a few other topics, we'll definitely be getting back on these variables and we'll explore even more concepts. Now I said a certain memory is allocated, but how much is dependent on the type of data. In case of integer, it's going to allocate 4 bytes of memory. In case of double, it's going to take 8 bytes of memory. Our next lesson is dedicated to understand how much memory does each data type take and their ranges. For example, you can't just give 10 zillion number here. There's a certain range within which the number has to be.